Well, unfortunately, in my haste to get home, I think I left my iPad, pencil, and the whole worksheet at school. So I'm going to do my best here. I'm pulling it up on my computer, though, and hopefully my finger will work a little bit for writing. Okay, so this is number 2. So this is the hamburgers at the Philly Sports Arena, cost $2 each, and they sold an average of 10,000 hamburgers. But then when the price was raised to $2.40, the sales dropped an average of 8,000 per night. So right there, they are giving you kind of 2 different situations, or in other words, 2 points. So when the price is 2, the amount sold is 10,000. And when the price is $2.40, the amount sold is 8,000. So when you want to find a price function, the output is the price. So you want the Y variable to be the amount. So when I make my 2 points here, so the first amount, 10,000 hamburgers. Sorry, my handwriting is going to be bad here because of I don't have the pencil with me. $2. And the other point is going to be 8,000 hamburgers if you raise the price to $2.40. Okay, so when it asks for, so those are the 2 points, and how do I know that I need to make those as points? Well, whenever you see kind of 2 situations like that, it's particularly involving price, it's probably going to be ask you for some sort of demand function or price function. And that is just relating price to quantity. So that's finding slope, y-intercept, the whole bit. So to find the slope, you would do the change in y, so 2.4 minus 2 over change in x, which is 8,000 minus 10,000. And just simplifying that, that's 0.4 over negative 2,000, which actually is negative 1 over 5,000. Again, I didn't design these problems to be like non-calculator friendly, so I would imagine, be having nicer numbers to work with. And then, like me, you like to use the point slope, so at least at first. So I would say P, because the price function, so P is my Y value. P minus 2 equals my slope, negative 1 over 5,000, X minus 10,000. And then simplifying this, you're going to get the price function in terms of X is negative 1 over 5,000 X. Negative 1 over 5,000 times negative 10,000 is just 2, plus 2, but then I'm adding the 2 from the other side, so it's going to be plus 4. So that's your price function, or your demand function. Kind of those words are used interchangeably sometimes. So to find the revenue function, because remember it's saying maximize the revenue. So this is at least part A. So revenue is quantity, which is X, times price, which is what we just found, the P of X. So that's going to be, if I multiply this function, the demand function or price function by X, I get negative 1 over 5,000 X squared plus 4X. So that's my revenue. And then to max that, you do the first derivative, set it equal to 0, and so on. Again, I didn't choose the friendliest of numbers, my apologies. But you get that when you do that and do the second derivative, you confirm that the 10,000 is the X value. So careful with this. 10,000 is the X value that maximizes the price. And so you can look at my work for that. Again, I was setting the first derivative equal to 0. Then with the second derivative, I'm confirming that it, in fact, is a max. And then it's asking for the price that maximizes. So once I get that X is 10,000 is a max, I just plug it back into the price function. So P of 10,000 is negative 1 over 5,000 times 10,000 plus 4. So that would be negative 2 plus 4, or $2. So that was part A. Part B is really, you've done the hard work. The part B is now you're maximizing profit. So profit is revenue minus cost. So you already found the revenue. So be careful, in part B, I'm doing big P of X versus little p is the price function. So the revenue function was negative 1 over 5,000 x squared plus 4x, and subtract that the cost, which I believe I gave you. It was $0.60, not $60. Fixed cost, so the cost function, sorry, I should write fixed cost, meaning no matter how many I sell, the cost per night is 1,000, but it also, there's a cost 60 cents per hamburger. So that's the cost function you're going to subtract. And then once you do that, then you'll see in my work that you have a profit function, you're finding the first derivative, setting it equal to 0, and you get 8,500. Oh, you know what I didn't do there? I should have, to be more complete, to show that that in fact is a max, I should have taken the second derivative, and the second derivative is always negative. It's negative 1 over 2,500, so it definitely would be a max because it's concave down. And then once you find that x, once again, it's asking for the price that gives you maximum profit. So put that number back into the price function.